Let's take a look at this problem. We need to find two numbers whose difference is 100 and whose product is a minimum. Why don't we let x and y be these two numbers? Be the two numbers. Now, what are we given? We're given that x minus y is equal to 100. And we want to minimize the product. So why don't we let p stands for product, be equal to xy, okay? We want to minimize p. That's our goal. Now, we need to get p as a function just in one letter. Let's say x, okay? So how can we get rid of this y here? Well, it's not too hard because, since x minus y is equal to 100, we can solve for y to get what? Well, if I bring this minus y over here and I bring the 100 over here, we'd have y equals x minus 100, right? And what I can do now is I can replace this y by x minus 100 because they're equal to each other, right? And instead of p this time, I'm going to write p of x now because now it's going to be a function of x. So x times y, and y is x minus 100. All right. Now, notice the domain of this is all real numbers, right? So the domain can be any value of x at all. A polynomial always has domain being all of r. Why don't we just multiply this out? So we get x squared minus 100x. So how are we going to find the minimum of p? Well, this is really just a quadratic. It's really a parabola that just opens up, right? So the minimum is going to occur at this point right here, right? The y value of this point. Usually we call it h comma k. So the minimum is going to actually be this k value. And h is going to be the value of x that gives that minimum. So we don't really need to use calculus here. We could just use our theory of quadratic functions. But let's just use calculus. So what should we do? Well, we're going to find the derivative and set it equal to 0. First of all, what is the derivative? It's 2x minus 100, right? So let's see when that's equal to 0. It's going to be equal to 0. So 2x minus 100 equals 0. That implies x equals 50, right? Well, to go slower, I'll bring the 100 over. And then divide both sides by 2. Those cancel, and I'm left with x equals 100 divided by 2, which is 50. All right, now we should really check that this is a minimum, okay? We could use the second derivative test or the first derivative test. Why don't we just use the first derivative test? Make a number line. This is 50. Here's p prime. If I take a number less than 50, let's say, 0, and put it in here, I'd have 0 minus 100, which is negative. So I know this is negative here. At 50, I know the derivative is 0. And for numbers bigger than 50, obviously we have a positive value there. So we see that at 0, the function goes from decreasing to increasing, right? And that means at x equals 50, there is an absolute minimum. And that's what we wanted, right? We wanted to minimize p. And we found out when x is equal to 50, the product p is minimized. There's nothing lower than that because that's the absolute minimum. Why don't we find y as well? Remember the formula for y? It was x minus 100, right? And since we know what x is now, we can plug that in. So y is going to be 50 minus 100, which is negative 50. So we've actually found our two numbers, right? The two numbers are 50 and negative 50. Notice that the difference is in fact 100, right? That's what we wanted. Note that 50 subtract negative 50 is the same thing as 50 plus 50, which is 100. That's what we wanted. And the minimum product is what? Well, it's 50 times negative 50, which is negative 2,500. I don't think the question asked that, did it? But it's okay to say anyways. So notice they just said find two numbers, right? We don't really care what the minimum number is for this product. All that's really being asked is to find those two numbers. But it doesn't hurt to write that. So we know that, let me just write a little sentence here. The two numbers are 50 and negative 50. And that's all there is for this one.